Hello, in the last videos we discussed what are grid algorithms and many different examples. Let's come to the next one. Here is the question, read it and give it a try. Given a string of length n that consists of lowercase Latin letters, each lowercase a to z is colored with either black or white. You can perform the following operation in a number of times, possibly 0 on the string. You can swap any two adjacent characters of the string s if the letters that you are swapping are colored differently. Find the lexicographically smallest possible string after applying any number of operations. So the question is saying that there is a string of length n and we have in on operation we can swap any two adjacent characters if they are of different colors, whether it is blue or white and white or black, white or blue. Let's assume that this is blue and white. So if these both are different, then we can swap the adjacent characters in one operation. So by doing any number of operations, we have to return the least lexicographical string that is possible. So for example, if there are two final answers AB and BA, surely it will be in the first order than this, because the first letter where these both differ is A and it is less, so it is the least lexicographical string possible. So given a string and each character letter, each letter color, we have to swap if they have different characters, different colors, and finally return the least possible string possible. So what is the first idea that is possible? So simply why can't we sort there? Because a simple counter example will be if all have same colors, all are B, then we cannot sort because we cannot do any one operation, because we should swap at least we should swap different colors, but here there are only blues. So obviously the answer is not directly sorting. The length is up to 105 and the count, they will give an array of size 26 where color of 0 will be blue or white, it will be of color A, and similarly of B, and so on till Z. So if this is a big string, and possibly there are many millions of operations that we can do, because we can swap any blue and white, and for example we may get many different groups where these are different, and we can try to sort this individually, but this is not correct, because let's say we have 4 different groups and here we have A, so we have to do operations within this first and then we can try to bring this here. But what if we have many different A's and many different cases? It will be surely different, because we can swap these both first or these both or any different number of choices. That will be very difficult to track and we cannot get an optimal answer. So now let's try to take a small example and simulate what is going on. Let's take we have only four characters and they are simply blue one and white one, blue 2 and white 2. Let's assume that is the simplest string possible of length 4. So what are the final possible answers? So let's say we are trying to swap these both B1 and W1, then it will be W1 B1 B2 W2. And if we try to swap these two, it will be this. And if we try to swap again these two, the middle one, then it will be this. And similarly, we can sort many different strings, many different operations, and we have to return the least one. So are you able to observe anything from this? Let's take a big example. So this is B1 and this is B2. Let's assume, before we assume that it is a simple string, the one is blue, one is white, and the next is blue and next is white. And now let's assume that between two blues, there are many whites and there can be many whites before and after as well. So we are at a blue and we are trying to look at the next blue if there are existing. So obviously if this is the next blue, these all are whites. Else, so obviously these are right. For example, if this is B, then we are dealing with this, but we assume that this is the next one, so all these are right. So now let's start operations. Let's start doing operations and observe something. So let's assume that B2 is A. So this is the least one possible. So we are trying to get this first because we have asked the least one. So B2 is A. So we are trying to bring A as fast, A as front as possible, so that we can fulfill our criteria. So we have start. So these are also white, and the middle also white, and the next are also white. These two are the only blues. Let's assume for now. So this is A, and let's try to swap with before one. So now it will be A, and it will be this character. And the next one, if we try to swap again, because this is blue, because we have swapped this, so now it will be blue. This will be white. So we can swap every two adjacent, because initially all are white and blue, and after that this is blue and this is white, and these all are white. So similarly like this, we can bring blue to the first one as well. So we can swap adjacent swap, and finally the first white is here and the blue is here, which is here. So after now doing the operation, it will be B2 and W, right? So we have swapped, we have brought A to the as fast as sprint as possible. So this is B1 and this is B2. Now can we do an operation to make this still front, to make this still beginning of the string? No, because we can swap only the adjacent ones which have different color. But these both are blue. So we cannot swap, we cannot bring B2 further. So this is the final position of B2. So we have assumed that we are at blue and we are dealing with the next blue. So these all are white, and for simplicity we assume that this is the least one. So now we are trying to bring it to the front one. What is the least index possible where this can come? It will be surely the next of the first B. Why? Because let's say we have swapped all these and finally the B2 came here, and now we are trying to bring this as before as possible, but this is not possible as these two are same color. So now the simulation stopped. So are you able to observe anything from this? B1, B2, and finally also B1, B2, because we cannot swap, we cannot bring B2 before B1, because obviously it should cross B1 to get before B2, before B1. So here is this. What I am saying is we cannot swap anymore to get B2 in the front of B1, because these both are same and we cannot swap anyone. So initially the sequence is B1, B2, and finally the sequence is also B1, B2. So order of blues is not changing and the order of whites will also not change similarly. So it is clear to understand that the sequence of blues and sequence of whites are not changing, because of this example we can clearly understand that initially B1, B2, and finally also if we are trying to swap and do operations, the sequence that is possible is only B1, B2 and not B2, B1. So order is not changing. So now what we can do? So we can store all the possible characters of which are blue in the blues vector and all whites in the white vector. Right, so initially let's assume that we have A, B and big string A, B, C, A, B, C, and they are given A is blue and all other are white. So we can simply use two vectors to store what is the sequence that have blue color and what is the sequence that have white color. So initially it is blue, so we can push into blue, and next it is white, so we can push into white, and the next is white, we can push to the next index. Why we are not sorting individually? Because we got a observation that all blues will not change and all whites will not change. So we have to keep all this in a sequence as in the original blues. So we are trying to store all this in the new, whether this can be Z, Y and tilts on A as well. We cannot sort this because we can only swap the adjacent ones. So even if we try to do the operations, the finally the blues can be only this. So we are storing the characters and storing in the blues and whites, and now we want the least lexicographical string possible with all these characters such that order does not matter. So we, from this example, we also understood that with the following condition, B1 must be next to B2 and white 1 must be next to white 2. If these both conditions are satisfied, we can bring any string possible, because B1, B2 are adjacent. The B2 is next to B1 and W2 is also next to W1, and similarly W1, W2, B1, B2, B1, B2, W1, W2. So if these both conditions are satisfied, then we can make any final string possible. So from these both vectors, we are trying to bring the least possible string possible. So let's say this is blues and this is white vector. So this is the final answer that we have to return the least possible string that is possible after doing operations. So what can be the first character of this? Can this be P or can it be M? No, because we discussed that the order must matter. So all blues must be in the same order as this. So this A should come first and then next A. Maybe not adjacent, but the next one should be A. And there are some whites and maybe this B. And there are some whites and then this B and so on. So what are the possibilities of the first character? Obviously it will be the first one of blues or first one of whites. Because let's assume that this is the blue of 2. Let's assume this is the third character of 2. Is this possible? No. Because before this there must be B0 and B1. But this is the first one. So obviously this must be B0 or B1. Only then our condition will be satisfied. So now we got that for the first index, it can be A or C. We want the least one, so which one can we take? It will be only A because it's the least one possible. Among A and C, A is least. So we are trying to add this here. And now we are going to this one and we are checking this and this, because A is no more here because we considered in the final string. And now the next blue that must come is this, and the next white that can be this. And now similarly we want the least one, so among this which is the least, so it is A, and now we can add A. And now we are thinking about this because we kept A here, and this is also solved, and it is B. And even now we can keep only B and C. B is less than C, so we can keep B here, and we can think of this now. So now the new character that we are deciding is P and C. So it must be P or C. Which one is better? We are trying to get the least one, so obviously C is the least, so we can keep C here. So it is C, and this we have added in the final string, so now it is D. And again we can compare DP. It is the D is less here, so we can add D and we can increase this, and similarly all, and finally we can get the answer. So in this way we can store the correct order of blues and the correct order of whites, and based on the least one that we are considering, we can add the least one of these, and we can increment the pointer where we have added. So if you know merge sort, it is exactly the merge sort function in the sort. So this is the given array, and we will sort this one and we will sort this one, and from this we want the least answer possible. So this is exactly the same case. We got the correct order and we got the white order as well. From these two we want the least one. So this is the same sort function that we use in the merge sort. So let's discuss the code. We are inputting the string and inputting the color, the size of the string, and this is the blues vector and white vector. Finally we are going to return answer, so string answer. And now we are traversing the whole string, and if the color of the present character is blue, we are pushing in the blue. If it is white, we are storing in the white. We are adding the present character to the white. And so we want two pointers to specify what are the least ones that we are going to consider, because let's say we have the four characters of the blue and four of white, and we have added these both in the answer. So we have to know that these two are the least index of blue in this, and this is the least index of white that we are going to consider, and only that can be added to the present index, whether this or this. So we want two pointers, so bp is equal to 0, this is the blue pointer and this is white pointer. And similarly we want the sizes of these both, so bn is equal to size of b and wn is equal to size of w. And now we can do simulation until the next case. Let's assume that this is a b c and this is p. So initially these both are a and p. A is less, so we'll increment this. B is less, we'll increment this. So we are adding in the final string as well. This is a, this is b, and this is c. We have added this as well, and we are coming to the next index, but there is no index because the size is completed. So what can we do now? So so complete traversing one string is completed, but there are some other characters in the second string. So what can we do? So there is no other possibility except that we have to add all the characters here to this one, and then we can increment. So let's say we have pqr and the first string is completed, but we have some other characters in this because this is not the end. Because if this then we can assume that they are completed, but this pointer is in the still the first one. So these are left, but we have to increment, we have to add in the final answer as well. So we can add p, and now we can increment the pointer. So we can add q, and we can increment the pointer, and we can add r. Finally we can reach the final string as well. So we can simulate until at least one character is left in the both. If the first one is out of the first string or second one is out, then we cannot compare those both because there is no character to compare with other. So we can simulate this until the first pointer is less than size and the second pointer is less than size. If it is equal to size, it means that we have crossed the first string and there is no character to compare. Then we can add the remaining characters to the string. So while bp is less than bn and wp less than wn. So if the present character we are considering of blue is less than white, then we are going to add blue in the final answer. So it will be answer plus is equal to blue of bp plus plus. So we are adding the b2 here and we are incrementing bp to the next one. So simply it is answer plus equal to b of bp plus plus. And similarly, if white is more, if white is less, we can add white as well. And then we are incrementing white pointer. And after completion of this loop, let's say we have some bp which is not considered. So this is the case, we have ABC and P. So After traversing, this will be our BP because we have traversed the whole string, and this is WP. So we have some characters in the white, so we can start traversing till it ends the character, it ends its length. So WP less than WN, we can add all the characters to the string. So while BP is less than BN, if there are any characters left in the first string, then we are adding in the answer and incrementing the pointer. If there are any strings left in the white, we are adding in the final answer and we are incrementing the pointer. So in this way, we can get the least lexicographical string by maintaining the given rules. So if you have any doubts, comment below. See you in the next video.